Hello there, welcome back. In this session, we will discuss about the post-process of fluid mix and heat transfer case in a 3D pipe. Now you can see in this project, flow mix and heat transfer in 3D, we have created a geometry, we have created a mesh, then we have set up a case, then we have also obtained a solution. Now we will see how we will be obtaining the result and we will discuss on the results. For results, we will select result and click here as add. Now here you can see we are having the geometry available like this. Now for making all this geometry visible, so what we'll do is select from here input, output and wall. All the equipments we'll select and make them as visible. Now here we are having the different command managers which we can select for preparing this result or just making you understand this result. Then first we will be creating the contours. So select the contour, click here as this. Then here we are having the option for variables for which you have to create the contour. So let's say I want to create a contour for temperature. Okay, then they will ask us the locations. So we'll select all the locations with control command and click here as OK. Then here they will be asking us the hashtag frames of contours. So let's apply it here as 200 frames and click here as apply. Once you select this apply option here, the process will be started and it will be completed in this way. Now you can check the mixing that has been taken place inside this pipe in this way. Now here you can see this is our input one from where we have inserted the fluid at a temperature of 293.15 Kelvin, and from this side we have entered a fluid at a temperature of 313.15 Kelvin. You can see from this scale we are having the blue color representing the minimum temperature and this red color is representing the maximum temperature. So minimum is from inlet 1 and maximum is from inlet 2. And here you can check the mixing is going on like this and it has been achieved on this position in this way. Now if you will cut a plane here, let's say if I want to cut a plane here and I want to make you visible more accurately, let's say I want to cut a clip plane here and I want to cut this along ZY plane, ZY plane or YZ plane and click here as apply. Now I'll click here as right click and clip plane 1 and I'll make you this visible like this or it will be visible like this. So mixing will be taking place like this. I hope it is clear. Now we can make multiple views. So this is our clip plane in which we have seen this as a mix. Now if you select here and here, let's say I want to make a streamline. In this, click here as streamline. Then here we'll select the option and input all the simulations. We will be selecting here in this case. First of all, make all these things visible. Now make this as let's say 500 frames and the formulation will be for velocity and click here as apply. Here also this is our view to cut another clip plane here and make it visible. It will be like this. Then click here as apply. Okay, Okay, no issue. Then we are having streamline. Select this streamline and here increase this frames. Let's say make this as 10,000 and apply. It will be created like this. Then I think more frames we have to require. Let's say let's make it as 1 lakh. Now we have applied a large value, so it's taking a bit of time. You can see the process. It has completed as 5% only. Now it has defined like this. If I want to show you the animation, how the mixing is taking place, you can check like this is at a different temperature and this is at a different temperature and how the mixing is taking place. I will go for animation from here and let's make this as single view only and define you the view 2. Yeah, this one, streamline. Now we'll make this process a bit slow. And select this as a streamline, select this as a loop and play this process. Now you see how the fluid is moving inside the pipe from both the inputs, from input 1 and input 2, and then they are coming in contact with each other and the mixing is taking place. Now this color representation is basically defining you the speed of the particles inserted from both the inputs. Now again the process will start from both the cases and it will be mixing in this manner. Now you can see the velocity is quite low for the liquid that is inserted from inlet 1. If we could improve the velocity for this, let's see what will be the change inside the project. So let's stop this. Now we'll close this. Before closing this, I'll just make you understand the results and all those things that we can achieve here. Let's say if you want to see the report for this, you can click here as report viewer and all the reports will be published like this. Then we go for 3D viewer again and select view 1 and now go for report. All these has been displayed here. Table viewer, chart viewer, let's make that change and see. So we'll go for setup, click here as edit. So all the things has been defined here already. We'll just make one change here. Let's go for physics, boundary conditions and input 1 and go for edit and make this velocity double, make it 0.8 meter per second. Apply, close. Now we'll go for solution, check the case, no recommendation, go for another, let's say 100 iterations and calculate. Now you can check the calculation has been completed. We have just taken 100 iterations for this case. I'll close this. Now let's move towards the result and open the post processor. So this is the contour one that has been created here. Now let's take the 2 viewer again in this way And this time, instead of view 2, we'll go with view 3. And here, let's select here and create one more contour. Contour 2. And make it for temperature again. And make this as 200. And define the locations as okay. And select all this input, output, and wall, all those things, and make this apply. Here also make this as no clipping and just display contour 1. Now you can check the mixing here and here. Not the much difference can be observed here. Let's say in this way. If we apply a probe here, like we are having the option for selecting the probe, let's say here change the option as temperature and select in this case. So this is 298.263. If we select in this case, so it is 299 point something, and here it is 299. Yeah, same it is coming for both the cases, but there will be a difference in streamline. Let's make here visible this view to streamline, and here make another view as view 4, and let's make this input 1, 2, 3, and 4 all visible, and zoom in it a bit like this. You can make another clip plane here, 3 along this same YZ, and select here clip plane 3. Yeah, it's visible. Then we'll go for streamline 2, define all the inputs, make this as, let's say, 1 leg, and apply. Now we have received the result for this case. Make this view a bit vertical in this way. Yeah. If we go from here, pan option, zoom in like this. So here we are having 2 mixing. Now we'll select this case and we will create a flow. Streamline 2. Let's say a bit slow. Loop and play. Now you can see in this case, both the fluids are coming in contact for a larger period of time. So we have to set our problems or our cases in according to this way in which the more mixing can take place, so that more number of temperature transfer could also take place. One more change that we can do in this design is we can make this inlet to at a certain angle so that the fluid could only is moving it in this direction, it should move in center of this outlet pipe. So you can just check this case and you can modify this case in which you can apply this at an angle and see the result. So in this way, we have seen the case of flow mix and heat transfer in the 3D pipe. I hope it is clear to you. You have enjoyed the session. See you again in the next one.